So it's over here, the vertex of it. And then let's go over 1, then 2 squared is 4. Negative 2 squared is 4. So the graph would look something like this. And then we're going to graph a line. So the line is going to be shifted up 1. Oh, for Vivian? Yeah. Oh, okay. So this one's going to be a line. The slope is 1. And so you want to find what is the area between the line and the curve and the quadratic. So what would be this area here? Basically, it's we don't have the before we would always just do something like this. You got something like a curve and you find area between, say, here going like this, and the bottom one would always be this x-axis, so we would be finding this area here. But now this x-axis could be something else, which instead of the x-axis is the parabola. So we're doing the top minus the bottom here. So it's the same, it's just that you have 2 curves instead of just having that. So let's do the integral of this to find the area. So the area is going to be the integral. So now here's another one that is important for you to understand, is it goes back to let me just give you already what we have here, the graph of it. There's the graphs. So basically what we're going to do here is going back to the definition of it, no? Is that we had rectangles, no? Infinite amount of rectangles here. And the rectangles, and whatever they are, left Riemann or right Riemann, something doesn't matter. But it's an infinite amount of rectangles that are stacked up, and then you add them up. And so we're adding rectangles from left to right. So this is going to go from left to right, and we're going to start where x is 0 to 3, where they cross each other. 0 to 3. On and on and on. But that's the idea of it, and it's the limit as you have an infinite amount of those rectangles, no? And so it's going to be the top function minus the bottom, no? So it's going to be this minus the bottom function. So what is the top function? X plus 1. And then we're going to subtract the bottom function, which is the quadratic, and make sure you put parentheses around it. And maybe we can go like this, and maybe we can go like this, and then it's dx. And there's the setup right there. Let's see. And it's all just algebra now, no? So let's do this on the side here. X minus 1 squared. What is x minus 1 squared? That will be x minus 1 times x minus 1. And multiply it out, it will be x squared minus x minus, so it's be minus 2x and then plus 1. So if we don't use a calculator, we'll just do it by hand. Area will equal to, from 0 to 3, x plus 1 minus x squared minus 2x plus 1, and the whole thing dx. So the area will equal to 0 to 3, So this is going to be negative x squared. Let's put the negative x squared first. Everything's distributed. Negative x squared. Let me do this first. And then I'm going to put this in the back. So there's plus 2x. And then minus 1. And then we're going to put this x plus 1 in the back. X plus 1. And now this is all just algebra. Erase this. What is this? Still from 0 to 3. Negative x squared. Is this plus 3x? And negative 1 and positive 1 cancel out. And the whole thing dx. And now we can integrate this. So yes, basically that's what it is. Let's continue. We just so integrate this. Be negative x to the third over 3 plus 3 halves x squared evaluated from 0 to 3. You see that the 0 when it's going to cancel out, so this is just going to be this 3. So that would be what? What is this when you plug it in? Negative what? Is that 27 over 3 is what? Is that going to be negative 9? And then what? 27 over 2? Plus 27 over 2? And then minus is going to be 0, the whole. You plug 0 here, this whole thing is 0. And so then here be, let's do this already here. This will be what? Over 2 times it by 2 here, to common denominator. So it'll be negative 18 plus 27. What's negative 18 plus 27? Is that 9? So it's 9 over 2, no? So the answer is 9 over 2. Hopefully we made no mistakes here in any kind of thing. So that is the answer, 9 over 2. 4.5 is 9 over 2. So that's the idea of this. Mainly you should already understand most of it. It's just algebra, and you're subtracting two functions instead of just saying that the bottom is the x-axis. So let's move on. Let's go to number 2 and keep going with this. So problem number 2 is find the area of the region R bounded by the graphs of the parabolas there. Basically say they didn't give you a graph. And how would you know which one is the top one and which one is the bottom one? And quickly it goes back to pre-calculus, and understand that y equals x squared. If you do rough sketch, which is all you're doing is trying to figure out where is it at, y equals x squared is some parabola going up regular, and y equals negative x squared plus 2x. If they do cross each other, more than likely more than likely the other one is, because it's upside down, negative x squared is going to be something going like that this one would be the top one and this would be the bottom one, more than likely, because the other one is going to be upside down, the other one's up, so this one's at the top and that's the bottom. And that's if they didn't give you anything. So So now we know that this is the top one and this is the bottom one. Okay, so now we need to know where they cross each other, no? So where do these two cross each other? So we set them equal to each other. So let's set them equal to each other to figure out where they cross each other. So x squared is going to equal to negative x squared plus 2x. If you move it over, well, that's what I'm going to do. I'm going to move everything to the left side. So this is going to be positive x squared here. And then you're going to minus 2x. I'll put it over here, so minus 2x. And then it's set equal to 0. Set equal to 0. And then this cancels. It's going to be equal to 0 here. Then you're going to get 2x squared minus 2x. And this is all algebra. It's just, and so we're going to factor out an x. And then it's going to be, what, 2x minus 2? I could have factored 2x out, no? 2x. Then it's going to be x minus 1. X minus 1. And so x is 0, because 0 times 2 is 0, 0 times anything is 0 equal to 0. This x is 0. And then x equal to 1. And so if you didn't get a graph, then that's how you figure out the lower and upper bound. But if they do give you a graph, even then you still wouldn't know, because they're not even giving you this number here. But we know this number got to be 0 for sure then. So yes. So let's integrate. So the area will be, or R, I'll find the area of the region R. So I don't know, R or area equals from 0 to 1. And we said that the upper one is negative x squared plus 2x. And then we're going to subtract x squared. So subtract x squared. And then dx. So 0 to 1. We can do algebra here. Negative 2x squared plus 2x dx. This is the area. Going to integrate x cubed minus 2 thirds x cubed plus x squared. 0 to 1. And hopefully if they give you this on a multiple choice, it's not algebra intensive. It would be something easy like this again. I think this is pretty easy. You plug in 1 here, then you're going to go and get negative 2 thirds. X is 1 squared, and if you plug in 0, this whole thing over here is going to be 0. Yeah, 1 to the third power is 1. This is minus 2 thirds. Plus 1 squared is 1, and that's just 0. And take away 2 thirds from 1 is what? 1 third. So there's 1 third. So that area is 1 third. So now we're going to use our calculators. So here, you can't really do, I mean, how the heck are you going to do this? Find where they cross each other. Find the area of the region R bounded by the graph. So that and that. And there's the graph, and there's no way to know where they cross each other. And how would you know which one is the top one and which is the bottom one? Yeah, that's the problem here. So So say they give you something like this. Maybe I would guess that you would want to graph it, and on the graphing calculator, it will show up. This will be all in blue, and then the graph will be blue, and this will be red. Y equals x to the fourth minus x is red, and the graph will be red. And you quickly know which one it is, and you're gonna do the find the intersection points. Remember how you were doing the intersection? You're gonna go from here and then go to here, and then it'll find you the intersection here, and then find the intersection here with the graph, with that intersection prompt that it has. So the problem is to know here is to know which one is the top one, which is the bottom, and where they cross each other. What are we gonna do? Let's go. Calculator. So you need a calculator. You guys can come get a calculator. So how are we gonna do? Solve to find where they cross each other? Am I gonna do solve and set them equal to each other for x? What's the best way? Or do what I just said, graph them and then do that little thing. Let's see, go to what? Go to graph, enter. Do I go to document and just create a new one? Nope. So graph it, tab it to get another one. No. Oh, okay, you can go up and down and redo it. Delete. No. X over square root x squared plus 1. Enter. So yes. So I see already it's in blue. The first one is the blue one. And then we're gonna graph. How do you add another one? Do I tab? How do you get another one on the same one? Okay, you tab. So then you're gonna get the second one, x to the fourth minus x. Enter. So there it is. So yes, I'm getting the same colors too. And what are we gonna do? We're gonna just do menu and go to actions. So we're gonna go to actions. Nope. Where do I go? Analyze graph. Analyze graph. We want to intersection. So move it over, enter. Is that how you do it? Enter and then move it over. No, oh no, I went too far. The heck? Menu, analyze graph, intersection. There, enter, move it over. All right, there it is, enter. Man, there's so much stuff going on here. Now move this out of the way. How do you move this out of the way? How do you hold it and move it out of the way? There's a little hand. Move it. Move it. Move it. No, move it. No. You have to move that out the way. Enter. Am I getting 4.59252? No. No, that's wrong. What is this? Oh, 0, 0. Why did I even do this one where it's definitely 0, 0? The one you need is the second one. Let's do another intersection there. intersection, and you're gonna go there, enter to, what the heck? Who got it already? Who did get it? Analyze graph, intersection, enter. Let me do one more time. That's one thing, is not enter, move it over. Yeah, enter. I am getting some, again, they're like on top of each other. Move out the way, get out the way. Am I getting 1.1 something? 1.18078? So there's that. We can go ahead and get those numbers. You know what? Get those numbers. We just get 1.181. So what did I do? 1.81. You know what? What I would recommend you do, use as many as you could, maybe 5, because that's cutting it too short for them. So I would use 1.18078. I would do all those 5, just to make sure you get it for correct. And they should have no problems with doing 1.18 all the way to 5 after that. In any case, then you just go ahead and do the integral of them, integrate them, whereas you already know which one is the top, which one is the bottom, and then do it. Yes? Yeah, that's how I'm going to do it. So basically that's what it is, and we're getting that as our answers, 0.785. So now we're talking about like the test. Any previous numbers that you round, maybe it would never hurt to do 5 numbers. So 1.18 and all the way 5 numbers. And then your very last answer should be rounded to the nearest thousandth, and it would be definitely have to be correct. You wouldn't mess up. Then you really, yeah. Next, number 4. So now we're gonna do area between curves that are expressed as the function of y, and I already have the graph for you there. There it is. So you gotta find the area of the region R bounded by the graphs of y equals x minus 1, which is the line. Y equals x minus 1 is the line. Then you got x is equal to 1/2 y squared minus 3, and that is a parabola that is solve for x, which is it's not a function now, but whatever. So you couldn't do it like this. Let's see. Why does it not make sense to do it like this? If I wanted to do these vertical rectangles here, it makes no sense to do it like this because it just doesn't work. You're subtracting the function, the same function, and then the bottom function is x equals the that parabola there. That's not going to work. So and so you try to find the area in between them. So this method is not working like this. So you have to switch it. And how do you switch it? Well, you're going to go, the rectangles are going to go like this. Whatever. So then this works. Because then you're doing, this is going to be, again, the top is top and the bottom is the bottom. That's for what we just did. And now which one is the top and which one is the bottom for this? The right is the top and the bottom is the left. So the left is the bottom. So now we know that's going to be the line subtract the parabola. All right. So let's do that. Because now you see that it's always going to be it's going to be on the line and then the parabola, and then this works. All of this, all the way through. So now everything's going to be in terms of d what. We're moving along d what, dy, no? Yes? Makes sense or no? The rectangles are moving, stacking them up dy. So everything's going to be dy now, not dx. And we're gonna do the integral, and the area is gonna go. What are we gonna do? Let's see. So we're gonna have to figure this out, and we're gonna have to figure this one out. Where they cross each other. So what are we gonna do? X. We need to find the x, or the y. Are we gonna find the y? No, we need the. We're moving on the y. So this is gonna be the y value. And in the graph, we do it's giving a 4, and it's giving us here -2. So by looking at the graph, and we're going from -2 to 4, that's easy. How can we find this without the graph? You would want to set them equal to each other here in terms of. Well, you were given. Let's move on because there's too many other problems we got to do, and we already do know it's -2 and then 2, 4. So it's going to be -2 to 4 for right now. That's for sure. Okay, -2 to 4. Okay, so everything has to be in terms of y. So the top one is the line. That's for sure. But there's a problem here. We got y equals x minus 1. So we got to put it in terms of just the way this other one is. So just move it over, +1. And now you got x equals y plus 1. So that's what you're going to do, put here, y plus 1. And that is the top one, we said, no? Top, and this is the bottom. And then we're going to subtract this. And good thing it's already in terms of x equals this. So let's go ahead and do 1/2 y squared minus 3. And the whole quantity dy. And you would put that, let's put that in a calculator. Yeah, we're not going to do it by hand. Let's just do it in a calculator. Whoa, okay. Let's do it. Is it going to recognize and understand it in terms of y? Let's just do it. Everything in terms of y. Integral. Go escape, go to calculate. Integral. Shift plus from -2 to 4. Yeah, I'm just gonna put that thing in there like that. I'm gonna use brackets real quick here. Brackets, like I have it. And then I'm gonna go parentheses. No, I don't need parentheses for y. Y plus 1. And then for that one, I need parentheses around the second one. I'm gonna subtract parentheses 1/2. I'm gonna put 0.5 y squared minus 3, and then dy. All right. Please work. Please work. Okay, I got this number. Yep. What you guys get? That's what I got. So it worked. It does work. I hope it. Another way to do it now. This is good. You don't have to save whatever. Yeah, that's just more like whatever it is. You could have saved it. 18 is correct. That's the idea of this. Let's go to number 5. Let's go to number 5. Let R be the region in the first quadrant bounded above by the graph. It's already telling you above is the cosine, our cosine. And below by that, what's the area of the region? Now here, let's see. There are a few of them where it doesn't matter if you stack up the rectangles going dy or dx. Why? Because if I do dx, look at it, dx, then it works. It works. No matter what, it works. This is the top, it's the bottom. But if I do dy, it wouldn't even, it doesn't matter anyways either. It doesn't matter. It does not matter because this is the top, that's the bottom. But let's see. Let's, but they already gave you. Oh yeah. There's no reason to change it. Leave it like that. Leave it at that. We're gonna do the dx. We're gonna do dx. Let's leave it as dx. But I think in what I have in the PowerPoint, I have it as dx. I have it as d what? As dy. I think I have it as dy. But anyways, so let's go. Area equals. Copy it down. Which one is our cosine? The green one or the red? Green. And how would you know? Because this is the square root of x. The square root of x function goes like this, and so it's like this. It's going like this, and then it's shifted up to. So it's gonna be 1, 2. So it's gonna be it's this one. So that one is the bottom. All right, so let's go ahead and we'll just do the calculator. Let's use the calculator. So it would be, well, you know, it's gonna be the top, and the way I'm doing is that it's gonna be 4 over pi arc cosine arc our cosine of x over 4, and then we're subtracting the quantity 2 minus square root of x, and we're doing dx because those rectangles are going that way, and so this looks to be 0, and this looks to be 4. But again, because I'm giving you the graph, and it looks to be that, but a lot of the times you would maybe have to go figure out what it is here and what it is here, certain what it is, no? But let's say it is, no? Because we just got to get going with it. It's just tedious work. Let's put it in the calculator, make sure that we know how to put this in the calculator. Shift plus 0 to 4. I will use brackets again. Just make sure, like just to have brackets around the whole thing here. I don't know. And then that first one, you don't need anything other than 4 over pi. Our cosine is actually the cosine inverse. That's what it is. Go to trig. Go to just trig, and there's cos inverse. Cos inverse x over 4. And then I'm gonna do minus parentheses 2 minus square root of x dx. All right, I got something. What you guys get?
426.
What the heck did I get? I got some weird number. I messed up, man. I messed up. Why am I getting some big old number? 2 point something?
2.426.
Dang! What did I do? What the heck happened here? 0 to 4? My number's messed up. I know it's wrong. All right. Well. Yeah. See, I changed everything in terms of why you don't have to be doing it like this. That's a lot. That's too much. So it's going from 0 to 2 and whatever. But it should be the same answer. Okay, but what is that though? What is that answer? What's 16 divided by? (16 over pi minus 8 over 3). Enter 2.426. I don't know what I did wrong. I got 289. I don't know how I got that. So, anyways, all right. Let's move on. Let R be a region for some x in the graphs. Well, we're not doing this. We're not doing it because that's getting too redundant. Let's just go look. If I was to do this, if I was to go like this, then it would just be. We could do it like this, and we don't need to do any of this. We could just go and figure out what this point is. What is this x value here? And then from here, we can integrate. It's just a regular integral. Just integrate this. And then just go and add the integral from here to here. And then the integral from here to here of this one. Yes or no? Makes sense, no? Yes? If we do here, no, it would just be the integral. Regular integrals. This would just be the integral under the area under the curve of here. And then add that area to the area under the curve of this function from here to here, and then it'll be the answer. But if we wanted to do this other way, then we do this minus this, and we want to know where they cross each other. Why don't we just go ahead and do it? You know what? Let's do it. Let's do it. Where do they cross each other? So solve. So graph it. Let's graph it then. And then find where they cross each other. Let's go ahead and do that. Let's find where they cross each other. And they seem to only be crossing each other one time right there. So graph them. Let's go ahead and graph them. Go back. Let's graph them. Actions. So delete all, enter. Graph. Yeah, you guys gotta tab. Oh, cleaned it up. All right. Y equals ln x. Ln x. Enter. And then tab it. Tab to get the next one. 4 minus x. enter it, and there it is. Yep. And we know, okay, so what are we gonna do? Look, let's do it like I just said. Why not? Why are we gonna just speed up through this lesson? Why don't we do, where do they cross each other? Let's find where they cross each other. Go ahead and do the intersection. Go to menu. Go to analyze graph, intersection. And then enter. Move it, enter. I am getting 2 point, what are you getting? Right. How do you move things around? How do you move it? How does it grab it? What are you guys getting for that intersection point? Is it 2.9?
Yeah, 2.926.
Or okay. So 2.9. How many am I going to use? 9.2, 9.926, 26, 9.2, 9.926, 27. All right. So that's X. And like I just said, this is what we're going to do. We're going to go ahead and do the integral because that's what X is. X is that number. I think it is. Well, and then we're going to do the integral from what? What is this number though? See, what is this? That has to be zero. I mean, I'm sorry, zero. It's one. What I mean, the one. It's one, no? Because that's just y equals ln x, and they all just go through one. Yes. So let's go ahead and do that. So you go from 1 to that 2.92627. 2.9. And you better write the numbers down correct. 2.92627. And of what? Or as this is ln x, no? Ln x dx. And then we're going to add, you separate them, and then we're going to add from what? From this. Yeah. From what? From this is going to become the lower bound, no? 2.92627 of this 4 minus x dx. And then what's the upper bound? So what is this? It's 4, no? Because x is 4 minus 4 is 0, no? And x is 4. So let's do that. Let's integrate that. Shift plus, we're going from 1 to plus from 2.9 to 4 of 4 minus x dx. Yeah, what are you getting? 1.7922. Look, I'm gonna go like this. Whichever one is the best way to do this, you would want to do it. It would be kind of, I know the lesson is about doing this, the lower this minus this or whatever, but whatever. You're supposed to do this minus this. We could have done it. We already got that. Let's do it because we do have it. What was this point? 2 point what?
2.9 to, what do we need the y equals 27?
you would need the y value of it. You would change it to that y value, yes. Because then you would go from 0 to that y value of it instead. And then you would do this minus that. Yes. If you want to do it, go ahead. It'll be correct. But you gotta, and then you gotta solve everything in terms of x equals, no? So how do you solve? Listen, how do you solve for if you got y equals ln x? How do you solve for x? So you're gonna do what? E to the, and so this cancels out. Or you could just go e to the power of y equals ln x. So this is the basis e to the power of y. E to the power of y is equal to x. Well, look at it like that. So x is equal to e to the y. And then this one, that's easy again. This is y equals what? 4 minus x. Move x over and then minus the y. So be x equals 4 minus y. And then you would just do integral of this would be the top is the line. So you just be 4 minus y minus e to the y dy. Then it'll go from whatever 0 and the y value of that. No? Whichever way you did in the calculator, it'll give you that. No? Need to fix this. 1.792, was it? Yeah. Let's go. Continue. I think this is it. This is gonna be. Yep. We got one more. One more. So this one, again, definitely you don't want to do, you wouldn't want to do these rectangles going like this for sure. Makes no sense to do that. And this one, it might work there, but there's no reason to be doing it like this. So this should be good going like this. But the thing is that it changes, no? This is what? The top is the blue one, and this is the bottom. And then there comes a point where they switch. Yeah? Makes sense, no? So we gotta do two integrals. So let's do that, no? We gotta figure out where they cross each other. We gotta figure out where they cross each other here, and where they cross each other over here. So let's go ahead and put it in the calculator, figure out what this is, What'd you guys get for that one? What was that? Is that -2? That's not -2, -4, is it? It is?
For the first one, yeah, I got it.
So let's do that then. Let's do that. So area equals from -2 to 0. Could we save these and then just do it? Huh? Save them? Let's save them. Let's find the other one. Let's find the other intersection point. What's the other one? Gotta zoom out. Let's see. What'd you guys get for that one?
That's it.
Also, 2?
The second one?
Uh-huh. Okay, so let's see. This say it is 2. So yeah, we're gonna go what? Which one is x cubed? So f of x is blue. The f of x. So we're gonna do f of x minus dx, and we're doing dx, and then we're gonna do plus from 0 to 2, and we're gonna do what is this? G of x, g of x minus f of x dx. So save it. I'm gonna save g of x or f of x. Oh, it already has something. You can go to menu every time and you make sure you clear A through Z and then start over, so it starts over. So you're gonna go with f of x is do we do the happy face on that? Did I call it? Yes? We do, huh? Yeah? F of x equals x squared plus 4x. Enter it. And then g of x. So we're gonna do shift plus from -2 to 0. What'd you guys get? 16. I got 16. I got 16. Let me see. I got 16. You add them. That's kind of like the idea, I think, and that's enough.